Hello everyone, my name is Karim Sayadi. I'm from OCTO Technology. I'm the leader of the augmented industry practice. It's a team within OCTO Technology. We work with several industrial clients to deploy data platforms for those clients, and do several use cases. One of the main use cases that we are doing with our industrial clients is the quality inspection. And today I will be talking about a very concrete example of how or why the data-centric approach is very important for the visual inspection. So before talking about why why data-centric approach is important and how we are using data-centric approach, first of all, what is visual inspection? So here a list of examples or projects that we did in the past, where basically, for example, for pharmaceutical industry, the use case here was to detect the contamination in the Petri dishes. And once the detection of the contamination is done, we send the results to a robotic arm that will discard the contaminated Petri dishes. We have we set a camera, a matricial camera that you see. So the example here. We have another example with thermal camera. So the use case was the welding. So we had to know the difference between the temperature of the welding in order to detect the defects. So here the hardware is different. We used thermal cameras, and we have another examples where we have to detect the corrosion in the indoor tanks of the vessels using a camera that was embedded on a drone. So the drone, so we fly drone indoors, and then we take the live stream of the cameras, and we process this live stream in order to detect the corrosions. So when we are talking about visual inspection, we are talking about this. It's to automatize and to make the inspection of something automatic. So the data, since we are talking about data-centric, our data here that is in the process of visual inspection is mainly images and videos, and it can be captured in with different type of cameras that are sensible to different light setting. This part is very important because when you train an algorithm, and when you train an algorithm, you need to have consistent data. So when you have different type of setting of light settings, you can have disturbance in the signal that you are trying to detect in those data. So here the data are the images. The main message here is that so with those data comes different challenges, and to build up a system of visual inspection, you are interacting with different constraints, with different parameters, and so on. So when you will build up a visual inspection system, for example, here with the drone, in order to detect the corrosions, you will interact with the business or with the experts that will tell you, okay, this is a corrosion, this is a type of corrosion, and the use case was, will I let the vessels come back to the sea or not, depending on the corrosions. So you have to include some expertise in your algorithm in order to detect the gravity of the corrosions. So you have to understand this, and you have to include this in your annotations. And you have to have the best data, or the data that describes at best the corrosion or the gravity of the corrosions, or the non-gravity of the corrosions, in order to send the correct message to the inspector that is taking the decision with your system. So the first interaction that you have when you are building this system is the business needs or the expertise. Then you have environmental constraints. So those constraints, so they can be like in the tanks, in the vessels with the drone. So you do not have natural light, so you have to have lights coming from the drone. You cannot as well have a lot of computation powers on your drone. So you have to deal with those constraints. And then the third part is the model development. So you will develop the model, your model. Your model has to have the best performance, because your experts or the business part will tell you, I want to have the best model with the highest performance, and you can spend a lot of time developing the model. This model has to be very light if you want to deploy it on a drone, so you will have a hardware constraints. And if you are working on a drone and you want to deploy your model or the artificial intelligence directly on your drone to have the prediction on live stream, you have to have a light model. So those constraints work together, but the central part of it is the data. Because if you are spending a lot of time building your model, if you are spending a lot of time having the wrong annotation or on your data, you will have an issue. So this is why the quality of the images is very important. How you translate the expertise that are given by the expert that are interacting with you into annotations is very important. And also the consistency of the annotation that you will have is very important in order to have the best model. So you have to find a trade-off between the performance, the latency, and the model development efforts. So to have a better visual inspection system, we need good quality of images, consistent annotation, and joint computation between the edge device and the cloud. So I did not talk about this point, but when you deploy your model on the edge, meaning the computational unit, whether it is a drone or any edge device that is on the production line, it's not the model that you developed. It's not a one-time effort. The model that you developed and then deployed on the edge will have a life cycle like any software. So it will predict on live data that the model was never trained on. So it can have good results, it can have a good accuracy or precision or recall, and it can have also bad results. So you need to upload rapidly the results in order to monitor your model and retrain your model and deploy again the model on the edge. So our conviction is we need to have an end-to-end approach from the hardware to the cloud services, and an approach where the quality of the data and the consistency of the annotation is very central to the visual inspection process. And this is why, so we build up a platform. So when I'm talking about this end-to-end, we build up a platform that goes from the hardware to the integration on the plants, till the cloud, until the AI frameworks, the MLOps part, the AI factory, and the labeling part. So the information comes from the edge and is uploaded to the cloud. And so I will focus only on the three main parts that are highlighted here in blue to explain why to explain why we need to have an annotation platform and the role of an annotation platform in a data-centric approach. So basically, if you so here is the details. This schema is the details of those three blocks. So once so you set up cameras on the production line, or you have your drone flying around the vessels, and you have images and you have photos that are taken. Those photos will be uploaded from the edge, and then they will come to this storage space. So the storage space with the images, and you will have also a storage space with the metadata, meaning the identification of the images and the prediction that are done in the live that are done on the production line or on your drone or wherever your edge device is deployed. Then, so once you have those, you will try to have you will try to collect the feedbacks from the prediction that are done. You have so we developed a KPI monitoring to monitor the performance of the model, and if the performance of the models are good enough, then be it, we will continue monitoring. But if we notice a tendency on that goes down, or tendency of the performance that is going down, then we will retrain the model, and therefore we need to prepare a data set for the annotation. And to prepare this, we will prepare it for here on the annotation platform. So here we have Kili technology, the Kili platform. We will prepare this set of data in order for the data to be annotated. And once the data is annotated, we send a record of annotation, and the annotation is stored. We send the annotation with the images to another block that is called here model arena. We called it model arena because we train a lot of models, and we compare the performance of a lot of models on different sets of data. On Kili, you can divide your data set on different. You can sample your data set on different samples, and you can train your model and compare the performance. So we can train the models on different subset, and we compare, and the model that is behaving that has the best performance, then we take this model and we deploy the model. We deploy the model on the storage space, and once we are sure that the model is okay, then we deploy the model, or we take it from the storage space to the edge device that is on the production and on the production line. So what is important with this schema is that this is done automatically. This is done automatically. You have very few human intervention. The intervention is to check the data set that is prepared, to do the annotation, of course, because the annotation is done by annotators, and then to check the performance of the different models. So here the main messages, the main message that we have is that consistency is key. So a model that it will learn from what it has been taught. This is my conviction. It's not a model. It's not something magic. You take deep learning is not magic. You take a CNN. Any architecture is a set of convolutional layers, but those layers will learn from the feature that are in the data. So if your data is, if the data is not of a good quality, or your annotation is not consistent, meaning that you annotate the same thing but with different annotation, you will have a model that is completely lost, and you can have an enormous amount of data. It doesn't matter. And this is why data-centric approach is very important, because you have to spend more time on cleaning up your data, cleaning up your annotation, rather than spending time on defining a very complicated architecture for your model. So for us to reach the best performance, you have to collect the first set of images with enough signal, and use a simple model architecture. Begin with a very simple CNN with few layers, or begin even with simple feature extraction model and a simple classifier. Then once you are sure about your signal and your quality and the data quality that you have and the annotation that you and how to annotate your data, then collect more data, process the images. You can then apply several augmentation techniques if you do not have enough data. Then you iterate once again, remove the annotation noise, monitor the variance between the annotator. Kili has also a feature on that to monitor the various. It's called consensus. So you can check the consensus between the different annotators. It's very important that the annotators on your project reach a consensus on the annotation, and then iterate again and correct the annotation. So once you have consistent annotation, clean data, then you will reach the performance in less time than if you spend a lot of time on trying to tweak the parameters of your model, or make your model more complicated. So in conclusion, and some takeaways, if you if you go home with a simple message from this presentation, it will be consistency, iteration, and automatizations of your process. Consistency of your annotation, iteration. You have to iterate rapidly in building up your model, and you have to have an end-to-end approach that is automatic, and you have to make sure that the human intervention is almost non-existent in your process. So if you have those three key elements, you can build a good visual inspection model. And a visual inspection system is a long-lasting effort. It's not a one-shot action, and this is why you need to build up this kind of architecture for your project, where the AI factory, the model, for example, here the model arena and the annotation platform or the annotation factory are central to your process, because this is a lasting effort. You have to annotate, train, evaluate, re-annotate, retrain, deploy your model, then redo again, monitor your model, then re-annotate, then evaluate, and so on. So the effort also has to be spent on the quality, the consistency of the annotation, and not the complexity or the complexity of your model or the parameters of your model. Of course, this is important, but once you have a good start, you have a good model, it doesn't matter. I mean, to add more layers or so on. Focus on the signal that you have on your data. And finally, an end-to-end approach is needed for joint computational capabilities. You have the prediction that is done on the edge, but you have to connect this edge to the cloud in order to monitor what is happening and not let the model drift away in its performance before retraining it. You need to monitor your park of edge devices in order to monitor the models and in order to retrain actively your models. So thank you very much, and have good talks.